Good morning, students. Once again, from after the long gap, we are meeting. So, after the completion of the topics from the first topic, moving charges and magnetism and matter. So, I am going to be switch over to the second part, the most fundamental topic, that is the 12th chapter, that is nothing but atoms. The atoms plays very important role for the development of what? Nuclear physics. That is, totally we can say that for the development of modern physics. Then what is the importance of that atom? Why we must study the atom? Studying the atom is nothing but studying ourselves. We are living in the world, in the universe. The universe is nothing but here, which consists of matter. The building block of the matter is nothing but atom. What the atom consists. All these factors comes under in what? The atomic physics. The building block of the matter is nothing but the atom. The atom consists central hardcore material called nucleus. The study of the nucleus individually that leads to the new topic, that is nothing but nuclear physics. That is also one of the most important topic. Because of the nuclear physics, we are getting the power. That is the thermonuclear. That is nothing but nuclear power station. We are generating the electricity continuously. Tremendous amount of the energy is going to be developed. So all these factors are very important factors. So that the study of the atom plays very important role. That is nothing but our planetary system is completely based on what? The atomic model. We have studied the Kepler's planetary motions. In Kepler's planetary model, whatever the sun is there, around the sun there are the planets which are revolving around the sun by keeping the sun as a focus. We have studied the different laws. That is completely based on what? This atomic structure. The structure of matter that shapes the world is one of the important matter for the study. The structure of matter that shapes the world is one of the important matter of the study. First atomic structure is proposed by the scientist Dalton, that we are going to generally say that Dalton's atomic model. He postulated the atomic model. Dalton first atomic model is going to be postulated by Dalton. According to him, the building block of the matter is nothing but atom. Then after that, it is modified by J.J. Thompson. Then we can say that Thompson's atomic model. Again it is modified by Rutherford. Again certain drawbacks in the Rutherford atom model is going to be modified by Niels Bohr. Then we are strictly adopted with what? Bohr's atomic model. He has also certain drawbacks. The small drawback is going to again rectified by what? Vector atom model. That is nothing but the electrons not revolving the circular orbit. The electrons can be revolved in a elliptical orbit concept is given by vector atom model. That is the small correction. So till today we are going to be accepting Bohr's atom model. So what is that J.J. Thomson's atom model? According to the J.J. Thomson's atom model, according to J.J. Thomson, atom is a positively charged sphere of radius 10 to the power of minus 10 meters. The concept of radius of atom is proposed, given by first time J.J. Thompson. His contribution is more. And what he said, in that positively charged sphere of radius 10 to the power of minus 10 meter, where entire positive charge and mass is distributed. Where entire positive charge and mass is distributed. In the atom, the negative charge particles are available, called the electrons. The electrons are available in the atom just like the seeds in a watermelon or plums in a pudding. The entire atom consists of positive charge and the mass is distributed. In that atom, there is a negative charge particles called electrons which are available or embedded like the seeds in a watermelon. Hence, the number of positive charges is equals to number of negative charges. Hence, the atom is electrically neutral. What is the importance of the J.J. Thompson's model? He proposed the size of the atom 10 to the power of minus 10 meter. In that, where positive charge and entire mass is distributed, in that atom there are the negative charges are available just like the seeds in a watermelon. The number of positive charges are equals to number of negative charges, hence the atom is electrically neutral. Then he explains successfully thermonic emission and ionization. He explained successfully thermonic emission and ionization. We know that what is that thermonic emission and ionization. Then after that, when the theory is analyzed, then what are the drawbacks that is found in J.J. Thompson's model? He is unable to give the explanation for spectral series of atom, hydrogen atom and hydrogen-like atoms. He is unable to give the explanation for large angle alpha scattering. Hence, this theory is discarded, not considered. Are you getting the point? So, if you want to understand the J.J. Thompson's atom model, just to take the half portion of the watermelon, just to think that the complete reduced portion, in that reduced portion there is a seeds of the watermelon. That seeds is considered as the negatively charged particle. The complete reduced portion, that is nothing but the positive charge, and the entire mass is that is distributed. Hence, number of positive charges is equal to number of negative charges. That is nothing but the atom is electrically neutral. The main important two factors should be considered here. One is the size of the atom, 10 to the power of minus 10 meter, and the atom is electrically neutral. Because of non-explaining the spectral series and large angle alpha scattering, now this theory is not accepted, hence it is discarded. Then, whatever the drawbacks is available here, J.J. Thompson's model, that should be modified, that is corrected by the scientist Rutherford. Then he has conducted the experiment, large angle alpha scattering experiment conducted by Rutherford, and he modified Thompson's atom model. Then what is that? Rutherford's experimental model for scattering of alpha particles. By conducting the experiment by Rutherford, scattering of alpha particles, then he proposed the atom model. What is that? Experimental evidence. Just you have to see it. So I come across here experimental setup of Rutherford. Rutherford's experimental setup for alpha scattering. So large angle alpha scattering, that is the base for what? Explaining the atom model by the Rutherford. Then what that experimental setup consists? So there is a lead block. The lead absorbs the radiation. Then he takes the lead block, and he needs the alpha particle. To have the alpha particle, we need the source of alpha particle. That is nothing but radioactive elements. That is nothing but bismuth 83-214. He takes the source of, this is the source of alpha particle. What is that alpha particle? Alpha particle is nothing but helium nucleus. Alpha is nothing but helium nucleus, helium-24. What is the charge of helium? 2. What is the mass? 4. So, there is a lead block. Now, these are the lead blocks. Now, these are the lead blocks. He makes a narrow opening to pass the alpha particle. Now, this is the source of alpha particle. What is that source of alpha particle? That is nothing but bismuth 83-214, which gives the alpha particles. When the alpha particle is continuously obtained from the bismuth 83-214, these alpha particles are made to be passed through a narrow opening. And these alpha particles are made to be passed on thin gold foil. Thin gold foil. Thin gold foil. What is the size of that gold foil? 0.21 micrometer or 2.1 into 10 to the power minus 7 meter. Now, this thickness of this thin gold foil is, the thickness of the gold foil is 0.21 micrometer, that much of the thin. So, there is a zinc sulfide screen. Zinc sulfide screen, and there is a detector. So, when these alpha particles are passing through the gold foil, how they are get scattered? The scattering of the alpha particle, on the basis of scattering of alpha particle, he gives the atomic model. Now, this is nothing but, it is caught by the detector. So, this makes the angle of scattering theta. Now, zinc sulfide screen. Now, this is the experimental setup. So, maximum alpha particles are passing through this gold foil. Maximum alpha particles are passing through this gold foil. Then, what is the conclusion? Now, there are the certain particles which are going to be get scattered. So, 1 of 8,000. Now, this is our experimental setup. Just see carefully. The Rutherford experiment for alpha scattering has got the lead blocks. There is a source of alpha particle, that is nothing but bismuth 83-214, which gives the alpha particles continuously, and those alpha particles are passing through the narrow opening and made to be incident on a thin gold foil of thickness 0.21 micrometer or 2.1 into 10 to the power minus 7 meter, and these alpha particles are going to be passing through the made to be incident on the zinc sulfide skin, and these alpha particles are passed through the zinc sulfide skin, and there is a detector. So, from the detector we can see the scattering angle theta. So maximum alpha particles are passing through the gold foil. Only the few are going to be scattered. One of totally 8,000. By making the angle 90 degree, rare alpha particles are going to be that is bouncing. That is the very rare. From this experimental evidence, maximum alpha particles are passing through the thin gold foil. And only few are going to be available by making the angle 90 degree or more than 90 degree of scattering angle. And only few, that is nothing but rare alpha particles are going to be what? Rebouncing back. Then what is that conclusion from the experimental evidence? When you go for the graphical evidence, number of alpha particles versus scattering angle. So this is nothing but 10 to the power of 1, this is 10 to the power of 7, this is 20, this is nothing but 140, like this. Now this is nothing but graphical representation. For the small scattering angle, we get what? Large number of particles. As the scattering angle increases, number of particles goes on decreases. It means that the maximum alpha particles are going to be passing through the gold foil. That indicates experimental evidence. In the atom, maximum space is empty. The maximum empty space is available in the atom from the experiment. Maximum amount of the alpha particles are passing through the gold foil. That indicates what? In the atom, the maximum space is empty. In that maximum empty space, there is a positively charged particles and entire mass is going to be that is constituted, and that is nothing but the nucleus. The building block of the matter is nothing but the atom. The atom consists of nucleus, where in the nucleus positive charge and entire mass is available. And remaining part of the empty space around the nucleus, there is a cloud of electrons. Whatever the number of positive charges are available inside the nucleus, the same number of negative charges are available outside the nucleus. That is nothing but the cloud of the electrons. Hence, the number of positive charges is equals to number of negative charges in the atom. Hence, atom is electrically neutral. Once again, are you getting the point? From the experiment, what it is concluded? The maximum alpha particles are passing through the gold foil by making the small scattering angle. That indicates that the atom consists of maximum empty space. In that empty space, there is a center core where the positive charge and mass is available. Entire mass and positive charge is available. Around that nucleus, that is called the nucleus, around the nucleus there is a cloud of electrons, negatively charged particles. Whatever the charges are available inside the nucleus, the same amount of the charges are available outside the nucleus. Hence, the equal number of positive charges and equal number of negative charges. That makes the atom is electrically neutral. Then, according to the Rutherford, he explained successfully maximum things. The size of the atom, that is nothing but 10 to the power of minus 10 meter. That is nothing but spherical in shape. The maximum space is nothing but empty space. In that empty space, there is an entire mass and positive charge is concentrated. That is called the nucleus. Then we come across the size of the nucleus. Then what is that size of the nucleus? How it is going to be determined? Then after that, there is one more factor. When there is a positive charge particle, alpha, and atom is nothing but positively charged. When the positive charge approaches towards the positive charge, there is a force of repulsion. There will be no head-on collision. There is a elastic collision. From the elastic collision, we can measure the impact parameter. Two things once again we are going to come across from the experimental evidence. So we come across next one, distance of approach. From the distance of approach we can estimate the size of the nucleus. Size of the atom is proposed by whom? J. Thompson. That is nothing but 10 to the power of minus 10 meter. From the experimental evidence of Rutherford, we come across there is a spherical, that is nothing but atom is a spherical in shape. It is having the size 10 to the power of minus 10 meter. In that atom, maximum space is empty. In that empty space, there is a positive charge and entire mass is going to be available, and that is nothing but called the nucleus. So we come across the size of the nucleus from the the distance of approach. Then what is that distance of approach? Shall I remove this one? Shall I remove? Yes. I come across distance of approach, that is I called R dot. क्या तो एक नाम दे दो. Interesting topic है. Just you have to be studied. किस लिए पढ़ना, क्यों पढ़ना? What is important? Getting the mass is not the important factor. Just to understand the basic concept. I come across distance of approach. Distance of approach. I call R naught. I take, this is nothing but atom, nucleus, positive charge, center of the nucleus, right? So when you come across, this is nothing but center. मैं यहाँ पे ले लिया मैंने, easy way. इधर 3 डाले, इधर 3 डाले, इधर 3 डाले. Maximum particles are going to be what? 1, 2. I come across here. ऊपर ले लेता हूँ मैं इसे. This is 90 degree. These are passing through the gold foil. A जो है सीधा जा रहा अल्फा पार्टिकल. ये पूरे अल्फा पार्टिकल है. It makes angle of scattering थीटा. छोड़ दो उसे पूरे. Right? इसको थोड़ा ऊपर ले लो. Right? When this alpha particle, that is nothing but alpha is nothing but helium nucleus. That is nothing but positive. When the positively charged particle approaches towards the positive force of repulsion, how long it reaches? It reaches to the very close to the nucleus. After that, it retraces back. Now this type of it is also type of the collision. Now this is called elastic collision. Without touching to the particle, if it returns back from its very closeness, then this is also called a collision. This collision is called elastic collision. अगर रोड पे हम लोगों का तो एक्सीडेंट देखते रहे, they are called head-on collision. That is nothing but inelastic collision. यहाँ पे elastic collision है. So when the alpha particle reaches very close to the nucleus at a particular point, so there is a small distance, small gap between the nucleus and the alpha particle. So there is a force of repulsion, it returns back. The closest distance between the alpha particle and the center of the nucleus, where the alpha particle retraces back, and that distance is called distance of approach. I call this is R naught. Approach होने के लिए ready है, but because of the electrostatic, strong electrostatic force, it is get repelled. And this, the closest distance where the alpha particle reaches to the nucleus and it traces back, and this close distance from the center of the nucleus measures what? Distance of closest approach. Now this alpha particle is having the mass m. When it is moving with a certain velocity v, Up to certain velocity it reaches to the nucleus. After that, because of the force of repulsion, it stands for a short interval of the time and returns back. यहाँ आने के बाद थोड़ी देर के लिए रुकता, कौन जब रुकता, which energy it has got? Potential energy. When it is moving, it has got kinetic energy. The complete kinetic energy is converted into electrostatic potential energy. Hence it obeys the law of conservation of energy. Inelastic collision is the collision where the momentum is conserved, the kinetic energy is conserved, hence the total energy is conserved. वही कंसेप्ट यहाँ पे आ जाता फर्स्ट ईयर में पढ़े सो the kinetic energy of the alpha particle is equals to electrostatic potential energy. It obeys the law of conservation of energy. What is that? Half m square. What is the electrostatic potential energy? 1 divided by 4 pi epsilon naught. Product of the charges. कौन से दो चार्जेस के अल्फा पार्टिकल है? चार्ज ऑफ द न्यूक्लियस. चार्ज ऑन द न्यूक्लियस झड. चार्ज ऑन द what? Z into E. Charge of the nucleus Z into E. That is nothing but the alpha is nothing but helium nucleus 2 4. What is that? 2E. Right? Divided by distance R0. Product of the charges divided by distance. एक बार देख लो पूरे इक्वेशंस को. पूरे इक्वेशन फिगर देख लो, then I come across what? The explanation. फिगर अच्छी तरह से फिगर को समझ लो. What is the closest distance of approach? Then I come across what? The equation factor, that is nothing but I need R0. देख लो फिगर को. सही है? राइट. चार्ज ऑन द न्यूक्लियस इज ZE, where Z is the atomic number. Nucleus is positively charged. Charge of the alpha particle, that is 2 times the electron, 2E. So I need R0. R0 equals to 1 divided by 4 pi epsilon naught 2 ZE square divided by half m square. So R0 equals to 1 divided by 4 pi epsilon naught 2 ZE square into 2 ऊपर चले जाता, that is 4 ZE square divided by m square. By considering the certain element, if we take the hydrogen atom, we know that Z, charge of the electron, mass of the electron, and the velocity. By knowing all the factors, it is estimated that R0 is nearly equals to 10 to the power of minus 15 meter. Sorry, 10 to the power of minus 14 meter. Now it is not exactly to the nucleus, it is very close to the nucleus. That never measures what? Radius. It is somewhat greater than the radius. Radius से ज़्यादा यहाँ तक radius है, उससे भी थोड़ा दूर है. It means that the radius of the nucleus is lesser than this 10 to the power of minus 14 meter. Now it is going to be obtained 10 to the power of minus 15 meters. So from this it is concluded that 10 to the power of minus 14 meter यहाँ पे estimation करें, उससे भी थोड़ा कम है. What is that? 10 to the power of minus 15 meters. So from this we estimate the size of the nucleus, that is nothing but 10 to the power of minus 15 meter, femtometer. So from the distance of closest approach, we estimate the size of the nucleus. So that is nothing but the radius of the nucleus is 10 to the power of minus 15 meter. It is found that R is less than R naught, therefore R is equals to 10 to the power of minus 15 meter. इसके जरिए हम लोगों को क्या पता चला? What is the radius of the nucleus? That radius of the nucleus is 10 to the power of minus 15 meter. It is obtained from distance of closest approach. Are you getting the point? The distance of closest approach is nothing but the energetic alpha particle moving with a velocity, and it reaches to the nucleus. At a particular distance, it retraces back. That distance between the point where it is retraced back from the center of the nucleus, that measures what? The distance of closest approach. कोई बात करने की जरूरत नहीं, फिगर सामने रख लो. क्या बोल रहा है? यहाँ तक पॉजिटिव चार्ज पार्टिकल है, यहाँ तक तो कोलाइड नहीं हो सकती. पॉजिटिव पॉजिटिव फोर्स ऑफ रिपल्शन नज़दीक आते ही टर्न हो जाता है. जब नज़दीक आते ही टर्न हो जाता है वो पॉइंट और सेंटर ऑफ द न्यूक्लियस, दैट मेजर्स द डिस्टेंस ऑफ अप्रोच. क्लोजेस्ट डिस्टेंस ऑफ अप्रोच, दैट इज नथिंग बट आर नॉट. इसका मायना क्या रखता है? From the distance, the closest distance of approach, R naught is estimated 10 to the power of minus 15 meter. उससे भी कम है वो radius. The radius of the nucleus is going to be found that 10 to the power of minus 15 meter. Till today we are going to be considering the radius of the nucleus is 10 to the power of minus 15 meter. So दो चीजें आप लोगों को मालूम हो गया. One is size of the atom, 10 to the power of minus 10 meter, proposed by whom? J.J. Thompson. From the scattering of alpha particles, Rutherford, from the experimental evidence, we come across size of the nucleus 10 to the power of minus 15 meters by studying the distance of closest approach. Distance of closest approach. Closest approach. सही है? अब इसके बाद वी कम अक्रॉस और एक चीज है. ये तो कोलिजन नहीं हो रहा. कौन सा कोलिजन नहीं हो रहा? हेड ऑन कोलिजन नहीं हो रहा. इसको कौन सा कोलिजन बोलते हैं? इट इज कॉल्ड इलास्टिक कोलिजन. डे टू डे लाइफ एक्सीडेंट्स आर नथिंग बट व्हाट? इन इलास्टिक कोलिजन. ये इलास्टिक कोलिजन है. यहां पे आई वांट टू मेजर द डिफरेंस बिटवीन द head-on collision and this elastic collision. The difference between the elastic collision and inelastic collision, that is nothing but impact parameter. Impact parameter measures the difference between the collision and head-on collision. Which collision? That is nothing but inelastic collision or elastic collision. में difference क्या है? That measures the impact parameter. That impact parameter is denoted by B or different letters. We can take here impact parameter B. So I come across impact parameter. What that impact parameter measures? The difference between the collision of the alpha particle and head-on collision. That is nothing but elastic collision और inelastic collision के अंदर difference क्या है? That measures what? Impact parameter. I come across impact parameter. Impact parameter. That is denoted by P. I take the nucleus. Right? So, charged particle So this is the point where the charged particle is deflected. Now this is the distance where the charged particle is scattered. Now this distance measures impact parameter. ये सेंटर है, ये परपेंडिकुलर है. the perpendicular distance between the center of the nucleus and the alpha particle which get scattered. That perpendicular distance measures what? Impact parameter. एक बार figure देख लो. Then we come across what is that. So बीच में जो positive charge डाले, so that is nothing but the nucleus factor. Are you getting the point? Now this is a alpha particle moving with a certain velocity. So impact parameter of alpha particle is nothing but the perpendicular distance of the velocity vector. Velocity is a vector quantity. The perpendicular distance of a velocity vector from the center of the nucleus, that measures the impact parameter, that is denoted by B. Right? That impact parameter is given by B equals to 1 divided by 4 pi epsilon naught Z square cot theta by 2 divided by kinetic energy half m square. Now this is the equation for impact parameter. Now it is theoretically analyzed and found that B equals 1 divided by 4 pi epsilon naught Z square cot theta by 2 divided by kinetic energy. देख लो एक बार equation. सही है? Where theta is the angle of scattering. क्या बोलते हैं इसको? Impact parameter of alpha particle. Impact parameter is the perpendicular distance of a velocity vector of alpha particle from the center of the nucleus. From the center of the nucleus is known as the impact parameter. It measures the difference between the elastic collision and inelastic collision. Right? Now these are the things we are going to be studied in the what atom. Right? What conclusion? The size of the atom is 10 to the power of minus 10 meter. From the Rutherford's alpha scattering, large angle alpha scattering, we come to know that maximum space in the atom is nothing but the empty. In that empty space, there is a small region where the entire positive charge and mass is concentrated. That region is called nucleus. The size of the nucleus is obtained from distance of closest approach, that is nothing but 10 to the power of minus 15 meter. Then what is the difference between the elastic and inelastic collision? That should be obtained from the impact parameter B. That impact parameter is nothing but the perpendicular distance of a velocity vector from the center of the nucleus. That measures impact parameter. That impact parameter is given by 1 divided by 4 pi epsilon naught Z square cot theta by 2 divided by kinetic energy of the alpha particle, that is half m square. Right? Then after this, in the next class we come across Rutherford atom model. Right? So then we enter the Bohr's atom model. Right? Then we come across what? Then nothing. So Rutherford atom model continuation करेंगे. उसके बाद क्या कमी है Rutherford atom model? That should be modified by Neil Bohr. Then we come across with what? The continuation of the topic, maximum with Neil Bohr. That is Bohr's atom model. Rutherford. Why the Rutherford atom model is going to be failure? That we come across the next concept. That is nothing but what the Rutherford explained in his model. Why his model is failure. Continuation. Experimental evidence होगा. उसके बाद में we come across what? The complete Rutherford atom model and analyzation. Then why the Rutherford atom model is failure. Then after that we enter in the what? Bohr's atom model. एक बार पूरा टॉपिक को अच्छी तरह से कर लो, पूरा ईजिएस्ट टॉपिक्स है पूरे। फर्स्ट जो है फर्स्ट बुक से ईजिएस्ट टॉपिक जो है सेकंड बुक्स में ईजिएस्ट वन। अगर अच्छी तरह से कंसेप्ट समझ ले, दैट इज द important factor. Is it clear? Shall I continue with next class? Yes. Thank you.